Let's take a quick trip down memory lane and let's try to remember how we first learned about long division in general. Not long division of polynomials, so just ignore this for a second, but let's just think about long division in general. So when we did long division, what do we say? Let's just make up a number. Let's go like 2494. And this here we would call our dividend. And let's go ahead and just say our divisor is 3. And I'm just going to write that. This is our divisor, right? Because I'm going to use these words quite a bit. So this is our divisor. Here is our dividend. Okay. Now, to come up with our quote-unquote quotient, right? What do we say? We asked ourselves, how many times does 3 go into 2? And the answer was, well, 3 doesn't go into 2 by division. Well, then we would look at our next digit and say, all right, well, does 3 go into 24? Now, I know you might be already bored right now, but hang with me. I promise it'll have a connection to what we're doing today. We're asking ourselves now, 3 goes into 24 how many times? And the answer is 8. And we know then we're going to multiply the beginning of our quotient, 8, by our divisor. So right underneath here, we're going to just say this is 24. And then we subtract it. And we got 0. We were then taught to bring down our next digit. And we said, okay, this is now 9. And we then asked ourselves, how many times does 3 go into 9? And the answer was 3 times. We then wrote 9, the product of those two numbers underneath, and we subtracted again. And then we brought down our final number, 4 here. And we asked ourselves, how many times does 3 go into 20, or 3 go into 4? And the answer is once. And then when we subtracted there, we got 1. And we were then told that this was our remainder. So we just said we're going to write 831 remainder 1. And we did that for a little while, and then at some point, your teacher probably said, all right, well now, instead of just saying remainder 1, let me actually also erase that as well. Instead of just saying remainder 1, now let's actually place a decimal place there, do it both in the top and bottom, and now go into the tenths place, which then allows us to bring out another number. So we're going to say now, okay, 3 goes into 10, how many times? Well, 3 times. And then we said, okay, we're going to rinse and repeat this process. So now I'm going to kind of zoom out a little bit. Let me actually make this a little bit smaller so I have a little bit more space to work with. And to rinse and repeat here, we said, okay, well, that's 1. And then we bring down another 0. And we said 3 goes into the 10 how many times? 3 times. And you already know the answer. We've done it now enough times where you're like, oh, wait, this is just going to keep on repeating. And that was a little bit of a missed opportunity for if your teacher didn't really connect what we were doing here with adding all these zeros and these decimal places with what we had previously stated there. What was that previous step? And I'm just going to go all the way back. It's almost like I'm rewinding here. When we had previously just remainder 1. Because when you have this value here, the quotient of 2,494, let me write this, 2,494 divided by 3 is equal to 831, and our remainder, which was 1, over 3. These are equivalent here, okay? So what we're actually then able to do is to say, oh, this was 1/3, which is approximately equal to 831.333, what we had seen there. And it was what allowed us to connect writing our number as a mixed number into this decimal form. That's really kind of how we approach that. And I'm going through all this trouble right now to remind you about this because I want to really emphasize here as we're about to start dividing polynomials that we're doing the same exact thing. So let me go ahead and clear this out of the way since we're actually now going to start working with some polynomials, but hopefully you'll see the connection here. So let's actually try this problem here. So we're going to actually do this long division, and we're going to set this up as follows. Let's see if I have some space here. I'm going to write this as 6x to the 4th minus x cubed plus 9x minus 3. And we're going to divide this all by x squared plus x minus 1. Okay? So what we're practicing right now, before I get too heavy into this, is how to do the long division of polynomials. Well, instead of trying to think how all of x squared plus x minus 1 goes into this dividend, just focus instead on the first term, and then focus also on this first term. We can see here we need to multiply x squared by 6x squared. Now, just like we did before, we're going to now multiply. This then gives us 6x to the fourth plus 6x cubed minus 6x squared. And I'm going to subtract all of this. Now, some people might prefer to distribute the negative now. I like to do the parentheses. It just forces me to really make sure that I subtract every term. So we would then say 6x to the fourth minus itself is 0. Negative x cubed minus positive 6x cubed is negative 7x cubed. Then, well, look here, be very careful. Do I see an x squared term in my dividend? And the answer is no, which means it's 0x squared. So you don't have to do this, but I'm going to actually just go ahead and write that in. Okay, so I'm just going to write plus 0x squared. Okay, you can always include that in. So 0x squared minus negative 6x squared, that's going to be positive 6x squared, plus 9x, and there's nothing I can subtract from 9x, and then minus 3. So now I'm going to rinse and repeat that. I'm going to go then on to the next one. I'm going to ask myself, how many times does x squared go into 7x cubed? Well, the answer is negative, well, it's negative 7x cubed, so negative 7x times. So again, minus negative 7x squared minus 7, all right, x cubed, excuse me, minus 7x squared plus 7x, and I'm going to subtract all of this. So then this is going to give me positive 13x squared plus 2x minus 3. We're pretty close to finishing here because now the degree of my dividend, or divisor, excuse me, is the same as what's in my dividend right now, low. So I'm going to say plus 13, so 13x squared plus 13x minus 13, and I'm going to subtract all of that. So that's negative 11x. So positive 11 minus 3, that's just going to give me positive 10. So here is my remainder. Well, if this is my remainder, what am I going to do with my remainder? I am going to say the following, that this here, let me just actually go back in, this quotient that I'm trying to find is equivalent to the following, 6x squared minus 7x plus 13 plus my remainder, negative 11x plus 10, all over my divisor, x squared plus x minus 1. And this is the result we get when we divide the numerator by the denominator. So if you recall, this is very, very similar, almost exactly the same as what we did. We're just replacing digits with dividing just numbers with terms in a polynomial. Now, this will always work, right? A long division will always work when we want to divide by a factor. However, we're typically only going to use long division when we divide by nonlinear factors because it turns out there's something else that we can use called synthetic division. And synthetic division is simply an algorithm that works under certain constraints. It's not the only way. Long division, as we just discussed, will always work, but what's nice about it is that it speeds up the process by quite a bit. And when can we use synthetic division? Well, when your divisor is linear. Is linear. So in the previous problem, we actually couldn't have used synthetic division, but we can use it here because this divisor is a linear factor. So how would we set up synthetic division for something like this? Well, I'm going to go ahead and set this up. The idea here is that we are going to invert that division symbol, and we're going to take all of the quotients here. In fact, let me actually go ahead and do this again. Let's move this out of the way. Hopefully everyone gets the idea that when the divisor is linear, let's move that out to the side. All right, here we go. So we're going to invert that division symbol. My goodness. Let's try that again. All right, and we're going to take the coefficients here, all the coefficients and the constants in my polynomial, my numerator, and I want to make sure I write them in descending order. So I'm going to say 3. Now, I don't see a cubic term, so that means I have to put in a 0. With a long division, that was optional, but with synthetic, since it's an algorithm, I've got to have that placeholder there, or else this falls apart. Then, what's my quadratic coefficient? Negative 49. My linear coefficient is positive 1. and my constant is just 20. I'm then going to take the 0 of my factor here in the denominator. So I'm going to say -4, and I'm going to place that on the outside. Here's how synthetic division works. Okay, let me actually zoom in on this. Here's how it works. I'm going to bring down my first number, 3. And I'm going to multiply 3 by -4, which is -12. So 3 times -4 is -12. I'm then going to place that product up here. So it's then going to go up there. And I'm going to rinse and repeat this process. I'm going to add this column now. So this is a big difference. We're going to add the column. So 0 minus 12, or 0 plus -12 is -12. -12 times -4 is going to be positive 48. So that product, positive 48, goes here. So 48. And then I'm going to add this column again. That's -1. -1 times -4 is positive 4. 1 plus 4 is 5. 5 times -4 is -20. And that's going to give me 0. Now, what does this all mean? What did we just find? What we're saying here is that this function, or this polynomial divided by x plus 4, is equal to the following. Each of these terms represent the coefficients of our resulting polynomial. And since we divided a quartic function by a linear function, we reduce the power by 1. So we start with a cubic. So we're going to say 3x cubed minus 12x squared minus x plus 5. And what does this represent? Well, it's our remainder. And just like we did before, we would have to say plus 0 over x plus 4. Well, that's just 0, so I don't really need to write that. The nice thing is when a remainder is just 0, you don't have to write anything after the constant. But let's say, hypothetically, had it been something like 8, then we would say plus 8 over x plus 4. But we don't have to worry about any of that. So this would be just the correct answer. Okay? So 3x to the 4th plus x plus 20 minus 49x squared divided by x plus 4 is indeed this. Okay?